Alrighty, full screen. So in the last video, the solving equations video, I kind of stopped with the cubic and couldn't do something mental math at that stage. And I don't like leaving loose ends when there's things to talk about. So gonna have just a little brief conversation here for those who really want to dive into things a little more deeply. All right, so we started with this graphing form in the last video, 3x minus 5 cubed minus 2 times x minus 5 plus 6. And I said I wasn't quite sure what it was here. Well, it turns out probably could have done that on the fly because pretty much everything we need to get that expanded comes from minus b over 3a, f of minus b over 3a, and c minus 3a squared. And we kind of have most of those numbers. So minus b over 3a has to equal 5. And so I got a. So I can solve for b. That would have been easy, minus 45x squared. And I also know that c minus 3ah squared equals -2. So I plugged in h is minus b over 3a, which is 5 in this case. And so I get c minus 225 equals -2. Well, then c has to be 223. Okay, and the last thing we've got is to find the y-intercept. Well, I can find the y-intercept of any function. Let's call this f of x, right? By plugging in 0. So I did that, and I got minus 359. And so that brings us over to this other side of the board, which you can see, but I'll center it a little bit to move the computer over. And so we have a cubic. Here, let me write this. 3x cubed minus 45x squared plus 223 minus 359. And in past videos, we've said, well, that's the tangent to the curve. Oh, I forgot the x. So I know the tangent to the curve right here. I know I'm going up at 223 to 1. Right? There's a lot of videos done before this that kind of show that with kind of precursor to calculus. You know, that's where I put a 0 in, go across, and then throw a 0.001 in, go across, and actually do y2 minus y1, x2 minus x1, and that number is going to appear. And so, said you can fill in the max mins, the x values pretty quickly now. Oh, this is without calculus. So where am I? Okay, so I got 5 and -2. That's all I need. So I'm centering from 5. I'm going in the positive direction here, and I'm looking at the square root of minus m divided by a. So that's going to be that x value, and this one's going to be 5 minus the square root of 2/3. Okay, so we're filling in a lot of stuff. But the last thing I wanted to talk about was, you know, how do we get that a value? The a value in a linear function, really all about rise over run. That's the language we use. I'm not sure it's the best language, but a in the quadratic is rise over run squared. So what's a in the cubic? So that's a nice little challenge. I'm going to erase everything that you don't need. You don't need that. You don't need that. You don't need that. There's enough information here to figure out how to find the a term of a cubic. So this can be a little challenge for you. You can work on it as long as you want. And then I'm going to tell you what it is down here now. So if you don't want that to be something that you can't think about, I mean, if you think about it and you get it, you're being a mathematician. You're not studying math. You are being one. You know, so how do you get it? Well, certainly the rise is going to be there. Yes. The rise is going to be there, but it's a little more complicated rise than we can imagine, because we've got two functions here. There's two functions. So how do I get from 6 to minus 359? I got to go down 365 units. Okay? And that's fine, because if I cube from 5 back to 0, if I cube that, I get minus 125. We're pretty close to 3 to 1 as a ratio. Pretty close. Sure would be nice if this was minus 375. Of course, I'd have to subtract 10. I wonder if you can stop again. Maybe you can spot where I'm gonna get subtraction of 10. Well, what happens when I plug, I'm gonna tell you now. What happens when I plug 0 into the linear component? I get positive 10. I don't want that. So how do I get rid of that positive 10 units? By subtracting 10, now I have minus 375 over minus 125, and I thought I'd just point that out. So it's rise, there goes the left right knee. So it's rise over, it's the actual distance changed minus the linear component. I'm not sure how I want to write that, but that's the numerator. And I think at least the numbers speak for themselves. So that's a quick addendum. I didn't want to end on, I'm not quite sure how to do that. So, went and looked at it and said, oh, yeah, it wasn't all that hard. All right, so I'm sure there's probably more to be talked about there, but at least I'm going to add that to the last video. All right. Middle of the day here. Everybody have a good one.